Hi, good morning. Good morning, everyone. So I am Prof. Lucy Campbell from the School of Mathematics and Statistics at Carleton University. So thanks for joining us this morning. I'm going to give a presentation on some of the features of our programs in mathematics and statistics. And while I'm presenting, you would have the opportunity to ask questions if you want to in the Q&A. And at the end as well, there'll be time for additional questions. I will also be in the booth, mathematics and statistics booth afterwards, starting from 12 o'clock, along with one of my colleagues, another prof from the School of Mathematics and Statistics. So I will just get started. Maybe a few more people will pop in over the next few minutes. So thanks to those of you who are already here. So I'm Lucy Campbell. I'm a prof in the School of Mathematics and Statistics. I am the chair of the recruitment committee in our school. And so this is my contact information, email information, and this is the email for the recruitment committee in the School of Math and Stats. So our committee is the one that deals with student admissions, and we're always happy to provide information for prospective applicants. So I thought I would start with maybe just a question, which I'm sure if you are here in this session, then you might be asking yourself this question, and that might be why you are here. So why study math and stats in general, not just specifically at Carleton, but anywhere? So if you are here in this session, you are probably someone who enjoyed math in school. Maybe you did well at math and you see it as a viable option for something you might study at the university and maybe make into a career. So why math and stats rather than any other area or subject that does involve math? So like there are many areas, other areas in science, application areas like engineering and so on, which make use of math. So why study math and stats specifically? Well, so I have this little cartoon that one of my colleagues found a while ago about math, where math lies in connection with all the other areas of natural and social sciences. I didn't include the applied areas like engineering and so on along this line, but they would be a little further to the left. Comparing math with the other areas, I hope you can see the text on this slide. The different areas in the sciences are related to each other along this spectrum of which area or which subject needs to make use of principles and ideas from the other. So sociology makes use of psychology, so the applications of psychology, and psychology makes use of biology, and biology makes use of chemistry in the sense of the theory of chemistry underlies some of what we study in biology, and in a similar way, chemistry is related to physics. So the physicist might be saying chemistry is just applied physics, but math is way over on the right of the spectrum here, in the sense that math underlies all the different areas of other areas of science and engineering and just about everything that we do in our daily lives, even when you may not be aware of the fact that you are making use of math. So for that reason, when you go to the university and study math as a discipline, it's it puts you in a very strong position to go branch out into applications in other areas. And so that makes the math degree a very useful one to have even because with regard to even with job prospects and so on, you can do a math degree. You could be teaching, you could be applying your math to different areas. That teachers, people to teach math, like at the university level, at the school level, all levels from kindergarten to grad school, are always needed, because every university, every school needs a math professor, a math teacher, and there are many applications, jobs that rely on quantitative thinking and quantitative skills that make use of math as well. So that's the power of a math degree. So, for example, I have a math degree and a doctorate, and I teach at Carleton University, teach math courses at Carleton University, but I also do research in areas outside of math. In my case, atmospheric sciences, and which is related to weather prediction and climate modeling and so on. And I use math to study those scientific problems related to the atmosphere and ocean by using mathematical equations and solving them. So that's the power of math. And still on why math stats. Well, as I just said, here are some of the different kind of areas that you can make use of math in. Areas that if you have a math degree, you are able to go into some of these areas. So fundamental research, of course, that would be what most of us as profs do in addition to teaching, but also research in various research institutes, including those run by the federal and provincial governments and so on within Canada. Academia, of course, education, so at all levels from elementary school up to university. Data analysis, actuarial science is a very important and popular area now. Finance, economics, information security, software development. So in many cases, while doing your math degree, you may also be learning some computer programming, even though you may not be getting a degree in computer science. So that's that knowledge of programming coupled with your degree in math puts you in a very strong position to do software development. And then there are applications in modeling in other areas, as I just mentioned, biological, epidemiological modeling. We hear a lot about that these days in connection with modeling the pandemic and making predictions. Environmental and climate modeling is important as well. That's related to the kind of research that I do. And then government work in many different government departments. So these are some of the areas that we can look at, you can get into with a math degree. Why Carleton? Well, Carleton fortunately benefits from the capital advantage, which is our location right here in the capital of Canada. And all the different government departments, government labs, other institutes, and many high-tech companies. So that puts our location puts us at an advantage with respect relative to some other options that you might have. And so now I'll just talk a bit about our programs at Carleton University, our programs in mathematics and statistics. So this picture shows the Hertzberg building on Carleton University campus. If we were doing this in person, we would be somewhere either in Hertzberg or in one of the nearby buildings presenting. In fact, we will be doing something, an in-person event next Saturday around this time on campus. So a bit about our school. We have a School of Mathematics and Statistics with approximately 40 faculty members, maybe a little bit more at this time, support staff, many adjunct professors who work in areas outside of the university, but have the opportunity to do research and collaborate with us in the department, in the school, and also can supervise students, grad students and undergrads, and also can sometimes teach courses. So we benefit from having people who work in, for example, the government departments, the high-tech sector, and so on, but might be have an affiliation with us through being adjunct professors, and students can benefit from that as well. At the moment, we have about 90 grad students and about 460 undergrad students in various programs. Within our school, all of us math professors also do research. And so each of us does research in a specific area of math, usually related to whatever we studied when we were in grad school, and which we've continued to work in. So algebra and number theory, applied and computational math, biostatistics and epidemiology, combinatorics, probability, statistics and data analytics, and theoretical and functional analysis. I'm a member of the applied and computational math group. And each of my colleagues is in one of these groups. Usually we teach courses that are related to our research area. So I teach courses, for example, like calculus, differential equations, and so on, to math students and to students from other departments as well. The other profs might teach like algebra, linear algebra, and so on, statistics, probability, and so on. So a bit about our programs. So there is a BMath general program, which is a 3-year degree. You get 15 credits. You need 15 credits. And there are 3 streams within the BMath, 3 programs within or sub-programs within the BMath general. So there's BMath in mathematics, in computer mathematics, and in statistics. So these are the 3-year degree programs. And then there's a combined BMath MSc. So jumping to the other end, this would be a degree for students who are interested in getting a master's degree, a BMath and a master's degree within usually about 4 years. So it's the same 15 credits plus an additional 4.5 credits. And the options are to do it in mathematics or in statistics. This is a special program which allows you, if you are really keen and you want to get a master's degree, and you can go through your courses relatively fast. It's a fast track program, which allows you to get a master's degree in mathematics after only 4 years. Then there are the honors program. There's the honors program, BMath honors, with different options: mathematics with a concentration in stochastics, applied and computational math and stats, within which there are concentrations in applied analysis. That would be sort of like calculus and differential equations and so on, applied probability and statistics, and discrete math. Discrete math would include areas like graph theory and combinatorics. And then there's the statistics program, and within that, there is a statistics with concentration in actuarial science. This is a very popular program and can lead you into a career in actuarial science. So there are specific courses dedicated to this area. This is a relatively new program that is becoming quite popular. Then in addition to the programs, the BMath programs that I mentioned on the previous 2 slides, there are also some combined honors programs. So mathematics combined with computer science or with economics, or statistics combined with economics. So these are also very good, it gives you a very good opportunity to study, get a BMath degree, but also learn about other areas, computer science or economics combined with mathematics or statistics. And within that, there is within the computer science and mathematics combined honors program, there is there are 2 concentrations: computing theory and numerical methods, which would be more on the math and computing side, and statistics and computing, which is more on the statistical computing side. So you'll be learning statistics, more statistics, taking more statistics courses than for the other option. So then also there is a BSc in mathematics and physics, double honors. So you see the regular honors programs, the BMath honors are all 20 credits. The 4-year programs are all 20 credits, but for the double honors, math and physics, you take an additional 1.5 credits. So that's an additional three courses. And you'll end up with a degree in math and a degree in physics, all done within the usual 4-year time, or possibly maybe with a little bit of maybe one additional semester, but usually done within 4 years. So now there are some features about our school and our options that make us kind of unique in comparison with maybe many other universities in Ontario. So one of them is that we have tailored first-year courses for our honors stream. So for all the BMath, 4-year BMath honors programs. And so unlike in some other universities where there might be math students might be taking the same math courses as other science and engineering students, at Carleton, in our School of Math and Stats, we have courses specifically tailored to the BMath first year. So we have, and also for the honors, BMath honors and the BMath general, so programs. So for the BMath general, we have some courses that are specifically tailored to first year students, calculus, algebra, and a mathematical reasoning course, which is a good course to take at the beginning to kind of train you in how to think mathematically, how to use the logic that you need to apply to succeed in your math courses, in your subsequent math courses. And then, so the BMath general first year courses, the computer mathematics option also includes accrediting in computer science, and the statistics program, statistics option requires computer science and some business information and communication technology course, as well as problem solving and computers. So all these are helpful for applications. So still on first year courses, we also have tailored first year courses for our first year honors programs. And again, there's a calculus and algebra and the same mathematical reasoning course that the general students take. Note that this calculus and algebra, especially this calculus course, 2 terms for 1 credit. So fall and winter for calculus and algebra. These are specifically tailored to the honors stream, honors program, and the ones I mentioned on the previous slide are for the general program. So we have separate courses for honors and for general. And in addition, the mathematical reasoning course is common to both honors and general. So all math students would take this mathematical reasoning course right at the beginning, which would help them with their subsequent courses. In addition, statistics and CAMS. CAMS is the Computational and Applied Mathematics and Statistics program. There is 1 credit, so 2 courses in computer science, taken jointly with computer science students. Now, so why math and stats at Carleton? So I tried to answer the question, why math and stats in the first place? And so I'm assuming that if you are here, then you are interested in math and stats to begin with. But why come to Carleton as opposed to elsewhere in Ontario or elsewhere in Canada or anywhere else? So one strong selling point for our programs is what I just mentioned, the specialized first year courses for the BMath honors and also for the BMath general. And so the idea or the advantage of this is we can avoid situations like this, shown in this picture here. You wouldn't be sitting in a class like this at any point. Huge class right way at the back. The microphone isn't working. You can't hear your prof. Or even on virtual, this year we are doing most larger classes virtually. You wouldn't be sitting in a virtual class with 1,000 students all connected virtually and getting very little attention from your prof if you needed to ask questions and so on. Our first year courses, and in fact almost all our courses all through through all through your tenure, the 4 years of the BMath degree are relatively small. So that means you are able to get support from your faculty, from the profs relatively easily. And you don't have to sit through these types of large classes. We do have some large classes like this, but not for our math students. The math students have their own special smaller classes. And you can interact more easily one-on-one with your profs and with your classmates and so on. So still, why math and stats at Carleton? So I mentioned the mathematical reasoning first year course. So that gives you a good start in mathematical and statistical reasoning abilities. There are math and stats courses that develop your quantitative and qualitative problem solving skills in general, and using abstraction to isolate the fundamental nature of problems, concepts and problems. So even if after your math degree you don't end up working in math, you'll have acquired some skills that you can continue to use for the rest of your life, in any aspect of your life, in your work or anything else you do, even in your personal life. Also applied training in data sciences and data mining, especially through the statistics program options, the concentrations available there. And the fact that we have these specialized courses tailored to math students allows us to really focus on developing mathematical and statistical reasoning skills and abilities. And in addition to that, we have computational facilities, state-of-the-art computational platforms, and a strong sense of community. So I'll just... the student-faculty ratio. So just somebody asked the question about the student-faculty ratio. So just going back to the slide where I mentioned some numbers. Yeah, so this is approximately what we have. So it's about, let's say, overall, maybe 1 to 10 faculty to students, but the faculty would include adjunct professors. Now, the adjunct professors are not always present or teaching at the same time, but taking into account that some percentage of adjunct professors are also involved in teaching, I would say the ratio would be about 1 to 10 overall. In our classes, we usually have, in the first year classes, we might have the cohort of first year students. So let's say maybe up to 20, 30 students, but maximum. But beyond that, the classes are generally smaller because different students would be in different programs and taking different sets of courses. Not all courses are compulsory for everyone. So there may be some small classes. I've taught smaller classes with maybe a minimum of 5 or 6 students, but also some larger classes with maybe in the 20 to 30 students. So that would be the case for in general in the honors program and also in the general program. So one-on-one related to that, there are a lot of one-on-one student-faculty interactions. So, for example, honors projects. I'll talk about that in a minute. And the co-op option for another strong point is the co-op option for the BMath honors, which begins after the second year. I'll talk about that in a minute. There's extra learning support through the Math Tutorial Center and the Math and Stats Learning Assistance Program. These are being done virtually this year, even though we are with most of the courses being virtual. And professional development, opportunities through writing, presentations, potential teaching assistantships. And when in your more senior years, you can get the opportunity to be a teaching assistant for some of the more elementary courses. There's a lot of social interactions. There's an active community of students that organized through the Math and Stats Math Society. They hold events like pancake breakfasts, barbecues, and so on. There's a colloquium series where they invite us, profs and others, to give talks about our research and things, so that students can learn more about math that they might not know from they see in their courses. There's an alumni series where alumni may come and present about the work they are doing and so on, the work they are doing past graduation. So the Honors Project, I just mentioned that. So the Honors Project is a research opportunity for a student to get the chance. It gives a student the opportunity to do some research, like being a grad, like the kind of research a grad student could do, but on just shorter term, usually done over one term. But in general, many students might start one term early and maybe spend 2 terms doing their work, and then officially register for it in the second term of their work, and complete it before the time they graduate. Usually this would be done in their 4th year of an honors program. Some students start it in their 3rd year, or in the summer before they start, the summer between their 3rd and 4th year. Usually by the time you've got to 3rd year, you've got an idea of what types of courses you are most interested in, and what type of courses you enjoyed the most, and then pick some area, and you might approach a prof who maybe you've taken a course with, and ask them if they want to supervise your research. So some students do original research. I've even had some honors students in the past who, after graduating, have got we've been able to after completing their honors projects, we've been able to publish their work. Sometimes you might be just exploring some known results, and then it gives you the chance to write a report and give an oral presentation. So develop those skills as well as your mathematical skills. There are other research opportunities. For example, there's the Dean's Summer Research Internship, which is done can be done in your 1st year. There's an annual competition through the Faculty of Science, and it allows first year students to have the opportunity to do research. And then there is the NSERC Undergraduate Summer Research Award Program, which can be done at any time from 2nd year onwards. It's an annual competition through NSERC, and if you get you apply, your prof that supervises you partly supports you, and then NSERC provides some funding, usually done over the course of a summer term. And there is the Co-op program. So for the Co-op program, you can be admitted to the Co-op program by the end of your 1st or 2nd year, or from high school. And you do at least 4 co-op work terms alternating with study terms. And this is one of the places where the capital advantage really helps us, because the co-op provides you with practical experience in the workplace, networking opportunities, financial support, and direct contact with potential employers. But being in Ottawa means that we are in close proximity to all these government agencies and high-tech companies that I just mentioned. So we have a tremendous opportunity to get your foot in the door working in some of these kinds of areas. And also, one advantage with the Carleton Co-op program is that there are longer work terms, so up to 4 work terms, at least 4 work terms, so that provides more in-depth experience. So that's kind of an overview of our programs. I thought I would end with just showing a couple of slides that give some testimonies from some recent grads, and just to give you an idea of the kind of work that some of our recent grads have been involved in. But before that, I'll answer the question, some questions. So international students get the opportunity. Do international students get the opportunity to work with government agencies? Yes, they do. You just have to make sure that you have the right clearance. So the right documentation to allow you to do that. So all that is done organized through the co-op office. So we have a co-op office at Carleton University. I'm sure they are presenting also here today. And they are the ones who would support you in getting all your paperwork in place to be allowed to do a co-op in a government agency or anywhere else. Can you take a variety of math stats courses in first year before deciding a more defined path? Yes, you can switch from one program within math and stats to another one. So you could start in one program, say if you are in the honors program, you would be taking the common honors first year courses. So once you've taken those, you could choose to, and if you've decided you want to go into one program, but then you decide to change, you could, as long as you've got the prerequisites to take the courses in the program that you choose to go into. But since the first year courses are common, after first year, you would usually have the opportunity to switch into any area that you want. So that's I think I've answered the questions that are in the chat right now. So yeah, so I would just mention, so feel free to ask any questions at this point. We still have another 10 minutes or so. While you are typing your questions, I'll just leave up these slides about recent grads. So this is a testimony from a recent grad who found a position at Health Canada. And after starting with the co-op program, so this is an example of what I was saying about the capital advantage and the co-op program. So this student did a co-op with Health Canada, and as is often the case, ended up working there, being offered a full-time position there after graduation. So that's one of the advantages of the co-op program. Here is another slide. The text is a little smaller, but another student who talks about the skill set that they developed while studying at Carleton University, which allowed them to get a full-time position in their field of study after graduation, and the unique blend of theoretical and applied understanding, which is what I mentioned earlier, gave them the tools to work as a data scientist. So someone is asking if, saying that they already applied for BMath, for the BMath program, but did not find the option of fast track of the master's. Can I opt for the fast track after I've got my acceptance to BMath honors? So to allow that to change, you can contact the School of Math and Stats undergraduate advisor, who's the one who would be in the position to help you to change. If you've applied to one program and you've decided that you want one program within the BMath options, and you decide you want to try a different option, different program, you can contact the School of Math and Stats undergraduate advisor. If you go to the math, good. Yeah, okay, great. Jalil has posted the link to the departmental advisors. Also, if you go to the School of Math and Stats page, math.carleton.ca, and click on the menu item people, it lists all the faculty and the staff, and listed among the staff is the undergraduate advisor who you can email for help with that. So any other questions? While waiting for questions, I would also mention this. I've put up another testimony from a recent graduate who is now working as a data scientist and makes use of statistical software and mathematical and statistical software. So those are opportunities that can be developed while you are a student. Okay, so it looks like those are all the questions that we have right now. So in the Q&A. So I would end the presentation quite soon. And just to let you know that I will be moving over to the chat booth for mathematics and statistics. And I will be there for much of the afternoon until 3:30, and a colleague of mine, Professor Jason Gao, will also be there. So the two of us will be there either at the same time, or at least one of us there between now and 3:30. So if you have any additional questions, you are welcome to drop into the mathematics and statistics booth and join any of the tables. You should see me there, and or see my colleague there, and just ask any questions that you want to ask. Let me just go to the. Okay. Okay, so we'll end the session at this point, and I'll see you in the next few minutes over in the chat booth if you have any questions. Okay, so thank you for attending this session. I hope you got some information from listening to the presentation.